Now let me do this integral by two methods. Now the first method, I'm using trigonometric substitution, which is let x squared is equal to tangent theta. Therefore, 2x dx is equal to secant square theta d theta. Well, then the integral becomes integral. This will be secant. This will be secant square, right? Theta, yeah. And this will be tangent theta. And dx will be secant square theta d theta over 2x, which is 2 square root tangent theta. I'm sorry, they're squeezed small places. And when x equals 0, theta is 0. When x equals infinity, theta is equal to. Now let me write another line. Okay, this one is equal to from 0 to half pi. And this will be secant square. X squared is tangent theta. Dx is a secant square over 2x. So secant square d theta over 2x, which is 2 square root tangent theta. Okay, a little better. So it's end up with this 1/2 integral from 0 to half pi square root tangent x theta d theta. All right, I hope everything clear now. Okay, so our integral becomes this. And I do have some other videos discuss square root tangent, but let me do this again. Okay, this is from 0 to half pi square root tangent theta d theta. Let me consider this one separately. Okay, so I'm using substitution. Let theta equal to half pi minus t. So this will becomes from half pi to 0, and theta will be cotangent t, and a negative dt, right? Yeah, I use negative to switch that boundary, so it becomes from 0 to half pi. Let me change the dummy variable, cotangent x and dx, right? In another word, square root tangent is equal to square root cotangent. Because of this, therefore my original integral is equal to 1/2 of half tangent plus this, becomes 1/4 from 0 to half pi square root tangent x plus cotangent x dx. Because they are tangent, cotangent, the same thing. Therefore, when we add them these two together, it becomes 1/2 of the I. Okay. So we have another half, therefore it becomes a quarter. Now this one becomes 1/4, and This is a sine square over cosine. No, sine over cosine. This is cosine over sine. Therefore, we add them up, become this. Sine x, cosine x. This will be sine x plus cosine x and the dx. Well, that's obvious to understand. Now then, I noticed that the numerator sine cosine dx could be written as d sine x minus cosine x. Sine x derivative is cosine. Negative cosine derivative is sine. Therefore, the numerator will become this. When I'm writing this, which means that I'm introducing a new variable, which is sine x minus cosine x. If I can change the denominator into that sine cosine, that means I'm integrating with this variable, this independent variable. Now, how can I change this one to this? Yeah, that's obvious. With the square root, this is square root. And 1 minus sine x minus cosine x square. This square plus this square is 1, right? So 1 minus cancel out. The remaining 2 sine and cosine. Now we have a sine and cosine, therefore I divide by 2. See, that will be equal to the square root sine and cosine. So this will be equal to, well, this 2 becomes root 2, right? Root 2. This is 4. Integral from 0 to half pi. And it become the d sine x minus cosine x over square root 1 minus sine x minus cosine x square. Well, I think this is quite familiar basic integral, which means d star or 1 minus a star square, right? So that one is equal to arcsine, isn't it? Arcsine, yes. This is the basic. So this is root 2 over 4. This will be arcsine. Sine x minus cosine x from 0 to half pi, right? Yeah. Then this equals to root 2 or now sine arcsine 1 is half sine minus negative, so that eventually that's equal to, this is equal to pi, so 4 root 2 pi. So that is the result for this integral, by method 1. Now method 2. Method 2 from from 0 to infinity x square dx 1 plus x fourth. Okay, now let me do the second method. Okay, the second method, I start with from 0 to this one, x fourth plus 1. Then the numerator is x squared plus 1 plus x squared minus 1. In that case, I will have a 2x squared on top, right? So I divide by 2, then equal signs back. Now, to do this, I want to split the integral into 2. So the first one is this, x squared plus 1 dx x squared plus 1/2 integral from 0 to infinity of x fourth plus 1 x squared minus 1. So I can do separately for these two. Now, if I divide by x squared both top and bottom, it becomes a 1 plus x, 1 of x squared, right? This will be x squared plus 1 over x squared. Yeah. And I do the same thing for this one. This will be x squared plus 1 over x squared. I divide by x squared, okay, 1 minus 1 over x squared dx. Now the reason of doing this, because I'm introducing new variable. The new variable is x minus 1 over x. See, that derivative is 1 plus x squared. And I have to change the denominator into x minus 1 of x, which means that I'm introducing new variable. I'm integrating with respect to x minus 1 of x instead of integrating with respect to x. So the denominator has to be changed into this form. How? Well, it's possible, right? This is x minus 1 of x squared. Okay. So this one, the first term, this one's the last term. The midterm is negative 2. So when I add the 2, see, then equal signs back. Similarly that this will be x plus 1 over x, isn't it? The numerator is 1 minus x, 1 over x squared becomes this. So the denominator must be in this form. So is it possible? Yes. This is square. See, I have this and that. The midterm is 2, so I take away midterm, then equal. See, the techniques of integration is that changing, then maintain the equal sign. That is the technique. Now, do you know these basic formulas? Let me find the using paper. This integral, d something square plus a square. This is 1 over a, right? Arctangent something over a, right? That is the basic formula. Or even you forget, you can derive very easily by using substitution or method or so. Now, well, since I I suppose that you can do it by yourself. I just skip. Same time for this, d star over star square minus a square. That one is equal to something like this, log star minus a star plus a, isn't it? That you can do it by yourself. I think, I believe you have done it before. So this one is equal to half half the formula. This is the formula. 1 over root 2 arctangent root 2, that is a squared. A squared is 2, right? This is x minus 1 of x from 0 to infinity plus 1/2 and then times 1 over root 2 log x plus x, 1 of x minus root 2, 1 plus 1 of x plus root 2 from 0 to infinity. Okay, so this one is equal to 2 root 2. Plug this one in here, this will be infinity, therefore it's equal to half pi minus, this will be negative half infinity, therefore it's negative half pi. For that one, when you put this is easy, you just take limit, right? Or use L'Hopital's rule. This will be 1, and log 1 is 0. Minus, put a 0 here. See, x, one of us could cancel out. You could have 1 again. Yeah. 0 again, log is 1 is 0. Therefore, this one is equal to 2 root 2 and pi, right? Yeah, if you multiply, rationalize this, it becomes root 2 pi over 4. Okay, that's the same answer. Same answer as we done method of 1. Thank you.